Hello everyone, my name is Todd Yates and this is my final project presentation for HI 7072, Leveraging Analytics and Business Intelligence Tools for Healthcare. Here's what we're going to cover today. I'll give you a brief introduction. We'll look into the data and data cleansing techniques, do an analysis of the methods for analyzing the data and the results, and then come to some conclusions. So the data set used for this project was the Framingham Heart Study, which is an ongoing and long-running study of the population in and around Framingham, Massachusetts. It was meant initially to study cardiovascular disease and has since expanded to include diet and exercise. The first step in the project was to gather the data and metadata and then formulate intelligent questions about what could be determined from analysis. Dataset was provided as a CSV file, and we were instructed to ask questions about the data that statistical analysis might be able to answer. Getting a familiarity with the data was key to formulating the questions, as some metadata needed to be analyzed and to then utilize the correct variables. And now we get to the questions. Number one, is there a correlation between body mass index, BMI, and men over 40? Question two, does smoking more cigarettes per day correlate to elevated BMI? Question three, does having high systolic blood pressure have any correlation to high blood glucose? Question four, does high blood glucose have any correlation to heart rate? Question five, is there any correlation between age and cholesterol level? My goal is to use the analysis results from these questions to be able to coach my friends and family on lifestyle choices that can improve their health. The data consisted of just over 4,400 observations and 4,400 observations of 75 variables. There was both categorical data such as male, female, and numerical data for such things as body mass index, heart rate, blood glucose, and many others. I first opened the CSV file in Excel to get an idea of which variables were available so that my questions would have a viable chance of being answered. No need to ask a question about brain cancer in a data set that focuses on cardiovascular health, right? Once I had those variables chosen, it was easy to look at the properties of the data that would affect analysis, such as NA values or missing data. The data chosen is in the table shown, starting with BMI 1, age 1, sex 1, sig-p day 1, cis-BP 1, heart rate 1, glucose 1, and cholesterol 1, total cholesterol 1. Of the 75 variables, there were also variable names such as age 2, age 3, etc., suggesting a time-based repetition of the same 25 variables. The number 1 categories consistently had the fewest NA values and were therefore chosen for the project. The existing data was examined in Excel to count NA values and could have easily been removed there, but to keep the most robust data set for each question, removing them in R was a better choice. To facilitate code construction, I also noted the column name, offset, and noted which question each piece of data would be used to answer the question. In which question. To get started, we import the CSV into RStudio using the read CSV function as shown. The next logical step is to subset the data by question so that each question subset can have NA values removed with as little negative impact to the overall data set as possible. Now we actually remove the NA values in each question subset. Question 1's data required unique treatment to subset on the male observations variable of sex 1 and age over 40. And once we had only male observations, we were able to discard the male variable. At this point, we have 5 nice, clean data sets that match the variables we need to answer each of our 5 questions. Question number 1 asks whether age and body weight, BMI, are correlated. We can use a statistical analysis in R to find the correlation as shown. The result shows a very weak correlation. The correlation coefficient of 0.134 is not a strong correlation, as a value closer to 1 or -1 for inverse correlation would be. We can see this visually also by doing a scatter plot of the data. Our conclusion to question 1 is that age and body mass are not highly correlated. The data does not show that older people are necessarily fatter people. Moving on to question 2, does smoking more cigarettes per day correlate to elevated BMI? In other words, do heavy smokers weigh more than light or non-smokers, and can smoking be used to regulate weight? The result of our correlation analysis is shown along with the scatter plot. Here we would be looking for a correlation coefficient of close to 1 to establish that there was a strong correlation. What we see instead is the value of 0.085. Viewing this as a scatter plot also shows visually that there's little to no correlation. The stratification in the scatter plot is likely caused by the data gathering techniques and has little statistical value. The visual impression is apparent though. Our conclusion to question number 2 is that there is a very low correlation to body weight and number of cigarettes smoked per day. Question number 3 asks, does having high systolic blood pressure have any correlation to high blood glucose? High blood glucose is considered a determinant of type 2 diabetes in a person. The correlation coefficient of 0.135 does not show a high correlation at all. To view the data visually gives the same impression. We can surmise that there is not a high correlation between systolic blood pressure and blood glucose levels. Continuing with our analysis of high blood glucose levels, question number 4 asks, does high blood glucose have any correlation to heart rate? The data shows a very weak correlation coefficient of only 0.088. A visual look at the data via scatter plot affirms that indeed there is little to no correlation between high blood sugar and an elevated heart rate. The final question in our analysis asks, is there any correlation between age and cholesterol level? Surprisingly, there is a very mild positive correlation of 0.249 between age and cholesterol. In a scatter plot of the data, we would expect to see a weak positive correlation, and we do. To summarize, let's start by restating each question and evaluating the impact they may have on my goal of coaching healthier lives for friends and family based on results of our analysis. Question 1. Is there a correlation between body mass index and men over 40? I think many of us may just accept that we all gain weight as we age and that there is little we can do about it. Our finding of a correlation coefficient of 0.134 shows that such a fate is not at all true. It is encouraging that weight gain and obesity are not something that we have no control over and must accept as inevitable. This finding in particular will be an excellent aid in my goal to be able to coach friends and family on a healthier lifestyle. We go to question number 2. Does smoking more cigarettes per day correlate to elevated BMI? Well, this is an interesting question for 2 reasons. Number 1, it makes logical sense that increased smoking would have a corresponding decrease in physical activity and therefore increase in BMI. Or 2, there are research questions about the effect of nicotine on appetite. Seeking whether there is a correlation between increased smoking and increased BMI would point to which of these 2 options is more likely. Our result, showing a correlation coefficient of only 0.085, would lean toward option 2, as there is little evidence that increased smoking raises BMI. My advice to friends and family here, though, is still going to avoid smoking at all costs. We move on to question 3. Does having high systolic blood pressure have any correlation to high blood glucose? High blood glucose is an indicator of type 2 diabetes, and some studies think that can exacerbate high blood pressure, increasing risk of stroke. With a correlation coefficient of only 0.135, we conclude that there is very little correlation between high systolic blood pressure and high blood glucose levels. Unfortunately, this result gives us little in the way of coachable advice. Question number 4, does high blood glucose have any correlation to heart rate? This question will again seek whether there is a correlation between high blood glucose, type 2 diabetes, and heart rate. Research in this area is unclear about whether high blood glucose causes elevated heart rate or if elevated heart rate causes high blood glucose or type 2 diabetes. Our resulting correlation coefficient of 0.088 suggests neither is the case, rather that there are other confounding factors that need to be considered. This too leaves us with little to contribute to our coachable activities for friends and family. Our final question, is there any correlation between age and cholesterol level? We all slow down as we age, but are other factors at play that we can't do anything about? It isn't illogical to think that riskier health conditions, such as high cholesterol, would be intensified with age. Looking at real data is the proper way to go about assessing this assumption. Our resulting correlation coefficient of 0.249 shows only a mild correlation between age and cholesterol, and this can be seen as good news, as it suggests that a high cholesterol level is something that we can, as individuals, have an effect on. My coachable moment here is to monitor diet and exercise levels to have a positive effect on cholesterol levels. My overall conclusion of this project is that data can be fickle when trying to make determinations and to guide decisions. Common assumptions can be disproved and often raise more questions than they answer. The cycle of an answer leading to additional questions can be seen to repeat over and over forever. But it's our curiosity about such things that eventually moves us forward. Thanks for your time.